Welcome to Grateful, where we provide online SAT and ACT instruction to students all around the world. Right now, we're doing a lesson on ABC factoring, which is a critical skill that you want to have before you go into your next SAT. So here's an example. If we had to factor something like this, yes, we could use the quadratic formula to solve this, but going into an SAT, you want to have all the different skills in your bag. So if we were going to go ahead and use factoring as our method, this would be called ABC factoring. Now, by the way, a quadratic is in the format of ax squared plus bx plus c, a parabola. If we had numbers here and here, that's BC factoring, and that's really, really common on the SAT. You definitely want to know how to do that. For instance, if we had y equals x squared plus 5x plus 6, you had better know how to factor that into x plus 2, x plus 3. If you had, instead of having numbers in the B and C spot, if you instead had numbers in the A and B spot, if you had numbers in these two slots here, that's AB factoring. And it does come up here and there on the SAT, and we recently did a video just on that. Today, we're focusing on a polynomial that has numbers in all three spots, like this one here does. And in that situation, you need two numbers that add to the B and multiply to AC. So the B in our situation is 11, and A times C, 2 times 12, that's 24. So what two numbers add to 11 and multiply to 24? So we want to take that 24 and divide it by everything we can. So of course it divides by 1, it also divides by 2, it also divides by 3, also by 4. And which of these numbers can add up to 11? Those two can. So we'll take the middle two terms and we'll split them into two terms that are equal to the 11x that we started with. So let's say 3x here and 8x here. So we have 2x squared plus 3x plus 8x plus 12 equals 0. Now at this stage, we have four terms. We have 2x squared, 3x, 8x, and 12. And when you have four terms in a polynomial, you need to know that the factor by grouping method is what you should do. So expect an SAT question that starts like this, just gives you four terms and says solve it. And you need to know how to use the method that I'm about to show you next. So let's go ahead and get started. For the factor by grouping method, you have to be able to take the first two terms and take a GCF out of those, and the second two terms and take a GCF out of those. So for the first two, the greatest common factor, the GCF, is x. If you factor that out, it leaves you with 2x plus 3. And for the next two, the common factor is 4. And if you take that out, it leaves you with 2x plus 3. So if you're not familiar with how to take the x and the 4 out and get the 2x plus 3 left, then maybe look up another video, one of ours or maybe someone else's video. Make sure you know how to factor out a greatest common factor from a polynomial. And now, an important checkpoint is to say that here, these two parentheses have to match. If they don't, then you did something wrong and you have to go back and figure out what that is. But assuming they do match, which they do here, you can take out the 2x plus 3, and when you do that, it leaves you with x plus 4. Now, why were we able to do that? Because we had two terms, this one, and those two terms both had a factor of 2x plus 3. So we factored out the greatest common factor there, which was actually 2x plus 3. Now it looks like this, and we can use our zero product rule, where we set each individual piece equal to 0. So 2x plus 3 equals 0, and x plus 4 equals 0. And just go ahead and solve. Take away 3 from both sides. Divide by 2 on both sides. With some better handwriting. And here, take away 4 from both sides. And our answers are negative 3 over 2 and positive 4. So let's go ahead and try another example here. Let's say we had 3x squared plus 10x minus 8 equals 0. So we need two numbers that add to B and multiply to AC. So what is the B? It's the 10. The AC is negative 24. So once again, we have a 24, and we'll lay out all the factors of 24, like we did on the last question. And we're looking for 2 that can add up to 10. That's kind of obviously this. But let's just follow our process when it comes to the signs here of saying that if it multiplies to a negative, that means they have to have opposite signs. So a positive and a negative multiplies to a negative, or a negative and a positive multiplies to a negative. So they have to have opposite signs. But they add to a positive, that means that out of the two numbers, the bigger one is the positive, because addition between a positive and negative is kind of like a tug of war, and the bigger of the two numbers is going to win. If the bigger number is the negative, it's going to be negative. If the bigger is positive, it'll be positive. So we know that we need these numbers here to have opposite signs, and the bigger one has to be the positive. So we'll put the plus sign on the 6 and the minus sign on the 4, and so that means that we're going to go ahead and factor this into, or just replace the 10x with negative 4x and plus 6x. We'll bring everything else down. 3x squared minus 4x plus 6x minus 8. And now we do our factor by grouping. What's the common factor here? It's x. That leaves us with 3x minus 4. And what's the common factor here? It's 2. And that leaves us with 3x minus 4. So plus 2 right there, 3x minus 4. And our checkpoint is to say that these two have to match, which they do. So we'll factor out the 3x minus 4. That leaves us with x plus 2. And now we can use our zero product rule, where we set each piece independently equal to 0. And we'll just go ahead and solve each one. So we added 4 and divided by 3, and on the other we subtracted 2. And so we have our two answers, 4/3 and negative 2. Going to another example now, slightly bigger numbers, 12x squared minus 31x plus 7. So our two numbers need to add to b, negative 31, and they need to multiply to a times c, 12 times 7, which is 84. And so, what are the factors of 84? They are 1 and 84. We can divide it by 2. 2 and 42 divided by 3. 3 and 28. And we can kind of stop there because 3 and 28 could add up to 31. Now let's deal with the signs. So they need to add to a negative and multiply to a positive. What kind of numbers multiply to a positive? Two numbers with the same sign, positive and positive, or negative and negative. What kind of numbers add to a negative when they have the same sign? That means that they're both negative. So now we have a little more of a clue of what needs to happen with our numbers. They need to both be negative. So we'll replace negative 3x and negative 28x and bring down everything else. And now we can do factor by grouping, which is factoring the first two and the second two using GCFs. So the factor for 12x squared and negative 3x is going to be 3x, and that'll leave us with 4x minus 1. For negative 28x and negative 7 and positive 7, we can factor out a negative 7. Now, let's just say we factored out a positive 7. Then that would leave us with negative 4x and positive 1. And so if we had factored out plus 7, these two guys would not match and we'd be stuck. So instead of factoring out positive 7, we'll factor out negative 7, and what's left over will now match. So this will be plus 4x and minus 1, because negative 7 times 4x is negative 28x. Negative 7 times negative 1 is positive 7. And so now the two parentheses match, and we can go to the next part of our process. We can factor out 4x minus 1, and it leaves us with 3x minus 7. Then we can do the zero product rule, where we set each piece equal to 0. add 1 to both sides, divide by 4, add 7 to both sides, divide by 3, and so our two answers are 1/4 and 3. Going to another example here. If C and D are the solutions of this and C is greater than D, what is the value of C minus D? And where is the above equation? One second while we deal with this typo issue. Okay, and we're back. So here is our sample problem. It's got 3x squared plus x minus 10. And it's a little more of the way the SAT presents things, which is a little more intimidating in appearance. But at the end of the day, it's the same question. So it's saying find the two answers. The bigger answer we're going to call C, and the smaller answer we're going to call D. And then we're going to have to do something with it. We're going to subtract C minus D. So let's go ahead and start our process. We need two numbers. They need to add to B, which is 1, and they need to multiply to AC, which is 3 times negative 10, negative 30. And so we'll start by getting the factors of 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. And the ones that are going to add to 1 are going to be these. If they add to a positive and multiply to a negative, okay, so multiplying to a negative means that they need to have opposite signs. And they add to a positive, which means that the bigger one is the positive one. So that means that the 6 will be positive and the 5 will be negative. So we're going to take that 3x squared plus x minus 10 and split it into either negative 5x and plus 6x, or we could split it into plus 6x and minus 5x. So one of these two combinations is easier to handle than the other, and I'm going to go ahead and solve them both to demonstrate which one is actually easier. So in the first example, we have 3x squared minus 5x plus 6x minus 10. And if we do factor by grouping, we can take out an x right here. So that'll be x times 3x minus 5. And then here we can take out a 2. So plus 2 times 3x minus 5 still equals 0. And now we can factor out the 3x minus 5, and it leaves us with x plus 2. And that is the easier way to do it. If we had put the positive first, it'll be a tiny bit more work. So we have 3x squared plus 6x minus 5x minus 10 equals 0. When we factor out the first two, the common factor is 3x. That leaves us with x plus 2. And then we have negative 5. And we have to kind of stop and think to ourselves, well, what signs do we need? Well, we need a positive x and a positive 2. And those signs tend to be very confusing for a lot of people. So at this stage, if you are confused, you can practice distributing back just to make sure you did it right. So negative 5 times x is negative 5x. Negative 5 times positive 2 is negative 10. And so what we're saying is, if when you find your two numbers that add to b and multiply to ac, if you put the negative first, it's a little easier. If you put the positive first, it's a little bit more work. But in any case, we can still get to the same answer. We can factor out the x plus 2. It leaves us with 3x minus 5. And we're at the same place we arrived at when we did it the first way. Now, we can set each piece independently equal to 0. And we can go ahead and add 5 to both sides and divide by 3. On the other one, we can take away 2 from both sides. And you have 5 over 3 and negative 2 as your two answers. So the wording of the question said that the bigger of these two numbers is the one that we'll call C. And the smaller one is the one we'll call D. The negative 2 is smaller because it's negative, even if 2 were a bigger number, still because it's negative, we consider that the smaller one. So what's C minus D? C minus D is the same as saying 5/3 minus negative 2. I'll put negative 2 over 1 because any number is really itself over 1, and we're going to need denominators, so we want to be seeing it as a fraction here. So get rid of the double negative, make that a positive. So 5/3 plus 2 over 1. And now we can get common denominators by multiplying by 3/3. 3/3 is just really a fancy way of saying the number 1. So we're not really doing anything when we multiply something by 3/3. But we have 5/3 plus 6/3, and that's why we have 11/3 as our answer, which would be D for this question. For our next question, we have this polynomial right here, and we're being told this expression equals something in this format. Find C. So a little more of that unique SAT way of making things sound more complex. But in any case, it's very similar to what we've already been doing. Always, in any situation, you should find the GCF whenever possible. And the GCF here, the greatest common factor, is 3x. All three of these terms have a factor of 3, and they also have at least one x. So if we take out the 3x, it leaves us with 2x squared minus 11x plus 12. So now we have kind of a two-part problem. We've got the 3x right here. It's going to kind of come along for the ride. And we've got the 2x squared minus 11x plus 12. That's going to kind of fill this part of everything when we're done. So let's go ahead and start factoring that ABC quadratic, 2x squared minus 11x plus 12. We need two numbers that add to b. They need to add to negative 11 and multiply to AC, which is 24. And so once again, our factors of 24. So those are all the factors of 24. And which of them can add to 11? That's going to be 3 and 8. But they're adding to a negative and multiplying to a positive. What kind of numbers multiply to a positive? Two numbers with the same sign. And for two numbers that have the same sign and add to a negative, that means that they're both negative numbers. So we're going to take the middle term, the 11x, the negative 11x, and split it into two negative numbers, negative 3x and negative 8x. We'll bring everything else down, the 2x squared and the 12. The 3x, we'll deal with that part later. Now we can do our factor by grouping. Take out an x right here. That leaves us with 2x minus 3. Take out a negative 4 right here, and that leaves us with 2x minus 3. Distribute just to make sure this went well. Negative 4 times 2x is negative 8x. Negative 4 times negative 3 is positive 12. If we had factored out positive 4, which is logical to do as well, we would have right here, we'd have negative 2x and positive 3, and now the two parentheses wouldn't match, and we'd have to go back and figure out what we did wrong. But now we can take out the common factor from here, which is 2x plus 3, and that leaves us with x minus 4. So we have our two factors that are equivalent to this part right here. And we can also bring down the 3x that was there all along. And what do we have now? We have it in the format that we need it, because we've got bx, and the b is 3. And then we've got the x minus 4, which is this piece right here. And we've got the cx minus 3, which is 2x minus 3. So seeing how everything lines up, it means that the b has a value of 3 and the c has a value of 2. This question was asking us to find c, so the answer is 2. And we're done right here. That's the answer to our question. And thanks so much for joining us on our video on ABC factoring to prep for your next SAT. If you'd like to contact us and find out how we can pair you up with a tutor to prepare you using online tutoring, this goes for students living anywhere in the world, go ahead and reach out. We'd love to hear from you. Thanks so much and have a great day.